Neutralization reactions. So when an acid and a base react together, they form a water and an ionic compound. Now remember, an ionic compound is when we have a metal and a nonmetal and a transfer of electrons. This is a special type of double displacement reaction known as neutralization reactions. So what's happening is that an acid has a really, really low pH of say 1, 2, 3. A base has a high pH of 13, 14, for instance. And when you combine the two, it ends up in the middle around 7. So that's why we call it a neutralization reaction, because it ends up like this neutral solution. So you need to know what the general pattern is. So when we mix an acid and a base together, we get this ionic compound and water. And here's an example. So if we took hydrochloric acid and potassium hydroxide, remember the OH always means a base. When you see a hydrogen in front, that means an acid. So that's my acid, that's my base. We get potassium chloride and water. Potassium chloride is definitely an ionic compound. There's the metal, there's the non-metal. So what you need to realize is, yes, when we have an acid and a base, we end up with an ionic compound and some water. You may think, why do I need to know this? Well, there's several applications for this. So the first one is treating chemical spills. So for instance, in the prep room, we have very, very strong acids, very, very strong bases. If, for instance, one of the balls were to break and it were to pour on top of me, I want to neutralize that reaction. I want to turn that into water as quickly as I can. So what we have is a couple boxes of baking soda just sitting there in the prep room, and that would be my first reaction. Grab the baking soda, pour it on myself or wherever the acid has been spilled. Let's say it was a base. I had sodium hydroxide, for instance, concentrated sodium hydroxide. Well, I don't want to throw baking soda on, that would make it worse. What I want to do is throw a very, very safe acid on it. For instance, vinegar. I put vinegar on my French fries. It's probably the only place I put vinegar, but I put vinegar on my French fries. That's acetic acid. It would neutralize the base, so I want to put something like that. Another thing is lemon juice. Lemon juice is actually quite acidic, and I squeeze lemons in my water to make like lemonade. I squeeze it on my fish. So that's when I say a safe acid is something that I find in my kitchen cupboard, which I know is not going to harm me. So you always want to do the opposite. So to neutralize an acid, you put a base in. To neutralize a base, you put an acid. So that's how we treat chemical spills. Another example is heartburn. So a lot of foods that we eat are very acidic, could give you heartburn. So what people do is they buy these antacids like Rolaids, for instance, or Tums. And that's basically a base that you chew, and it neutralizes the acid in your stomach. So we're adding some base, and it neutralizes the acidity in your stomach. Another problem that we run into is acid rain. So if you constantly have this acid rain, well, what it does is it increases the acidity in lakes and streams. That is a huge problem for plants and aquatic life. Plants, if the water gets too acidic, can't grow. Well, if they're not growing, we're not producing enough oxygen for the fish or food for them as well. So again, you want to find something that's safe for the environment, like a safe base to add, and that will lower the acidity of the lake.